You can see my screen now, sir.
Yes, yes. Kshitij, you are able to see it? So all of you have downloaded this program, right?
See, that whatever that TZZ file I have sent you and I have given the access, this is a file. And I already have given you, the sir will send you that PPT. So in the PPT, there are like configuration steps, how to do the configuration and all. Sir, you want me to do configure now also, or I just go through with this only inputs and all?
Show the entire thing.
Okay. So, okay, sir.
Starting from scratch, so
Yes,
that
sir. So this is the TZZ file. So you don't need to remember any steps. Already the steps I have given. You can just
so
follow.
Meenakshi, one thing. Now
Sir.
this code will run only on Linux systems or Unix or it will Windows also.
It will run general. I mean, whatever the commands I am using, it will run only in the Unix system, sir. So they can take the HPC account and they can run it without using any parallel thing.
So Kshitij, do you have an account in our Aqua HPC? No, sir.
Kshitij, I will share you the how to get your HPC account. Okay, in one day, if you have any guide in your BTech program or in dual degree program, so you can give his. I mean, you can get a request to
He's
sir.
a second year student only. Okay? So he will go.
Or otherwise, we'll give you the details of our account so you can run it. We have one more account where we can give you, so you can install this file and you can run it and you can get the results. I will share those details, the user account, password, and how to run it in the Aqua also. I'll show it in the last. First, let me show you that first, whatever the steps we have to do. Then I will show you in Aqua how to do it. Is that fine, sir?
Go ahead.
Yeah. So this is the TZZ file. So whoever having the computer of like Unix system or already have the Aqua account, everybody have to I mean incorporate this file, whatever this TZZ file, into that particular account wherever you are doing. That is in that path you have to keep it that file. So once you keep it, you have to unzip it. That is this tar minus xvzf Mineos, that file name. Once you give, it will undo it. So and it will give you this Mineos 1.02. Can you able to see, right? So once you untar it, this file will get formed. So once it gets formed, you have to give /configure. Otherwise I'll show you. There will be like executable, you can see. CD Mineos means you will go to that particular directory. So if you give ls, it will show you the list of files that exist in the directory. So this is the configure file. It is an executable file if it exists in green color, and you have to give /configure. It is like executing, like how we'll do like if we want to run anything, any application in Windows, it will give a pop-up window to whether it want to run it or not. So instead of that, we are giving through the commands like /configure. So once if you give the configure, it will configure according to our system. So once it configures, all the required things will get generated, and we'll do make that whatever the Fortran files are there, that it will get generated. Once if you get, we have to install all the things. Then the next step will be make install. Okay. So once you get into the make install, you can see the files. You can see here Minos brand, green, icon, cactusac, and one more syndat. These are the programs which will generate the eigenvalues, eigenfunctions, Green's functions, and finally the synthetic seismograms. So the first step will be untar the TZZ file. Once you untar it, you give the /configure. Once you /configure, you have to give make and then make install. Once you give all the things, then you will get into the final steps. So for this, the first step, before running to the Minos brand, you have to give the inputs. There are 3 inputs that are required. First is the model file. Here you can see model file is already there. Frame ocean.txt, frame no ocean.txt also there. You can see here, right? This is a frame model with no oceans, and it is like from zero, that is from the core to the total 6371 kilometers. Till that depth you have like VP, VS, rho, and also the QS and Q mu, the shear wave factors. And also this is one is this anisotropic case. So all these tables are all the models they have already given, and all these files you can find it in demo models. You can see here there is a C Pacific.txt, one type of model, N Russia.txt, one more model, frame no ocean.txt, frame ocean.txt. If you see the readme file, you can see what are the models and how they have given, and what is the directory contents exist in this file. So you have, if you are running it in the main folder, you keep that frame no ocean.txt in the path where we are running in the Mineos folder, not in the demo folder, but you have to take that model and then you have to keep it in the Mineos folder. If you are having any doubts, you can ask that itself, so that I'll also let you know if I'm making any confusions or not. The models are whatever the existing models exist only in the demo folder. So when you're running it, you have to keep that models in the folder where you are running. It is clear, right?
Yes.
Yes. So this is a one input file where the input, frame is an Earth model. It is already given. If you want Mars and Moon thing, there are material properties already given for that, and those papers I will share you or sir will send you. So you can also make your own inputs by following the similar procedure how they have made the frame model. And I will show you the one second. I will show you here. If you see, while you're preparing your own model file, they have given like NIC, NOC, that three steps, like 111. What is that? The next layer is 188, 185, 35, and 66. Those numbers are given, no? So what are those numbers and what are those columns? Everything are given in this manual. I'll show you once again that frame no ocean, and I will tell you what is that. You can see here 185. This 185 represents the number of lines in this program. In this file. There are 185 lines excluding this top three lines. If we should not count this top three, so the remaining are 185 lines, and this 33 represents the interface where the outer core and the inner core boundary exist, and the 66 is the where the fluid outer core and the mantle boundary exist. So those values like 33 and 66, that depends on your how you're writing your own model. So if you have your model with the core bound, mantle core boundary at a 2 or 3 limbs, then you have to give here a 2. So based on that, you have to write your own models. So this is one input. Another input is CMT solution. This is the CMT solution. This is the event name, year, time, and also these are the lat, long, focal depth, half duration, and also this is like a moment, okay. Sorry. This is the M naught. It is a factor like seismic moment. What is its value? And these are all the 6 components. And it's in terms of dyne centimeters you have to give, and these three are the fault plane components: strike, dip, and rake angles. That also I will show you where it is given in the. Okay, this is the CMT file, right? So the event name, the year, date, minutes, seconds, lat long, depth, step function, I mean Green's functions, what is the time step, half duration, this M naught, it is in dyne centimeters. These are the components that you have to give, and the strike, dip, slip of the first fault plane solution, the second fault plane solution. Even if you don't
Don't
know
need
the.
to worry. Okay. So as this course, this assignment, whatever I'm asking you, so CMT solution, no need to. You can use the default whatever is available in Mineos. Okay. So no need to change anything. So you will use the same thing, and you will use it for Moon, Mars, and other planets. The more importance is given for the velocity model. So if you take variety of velocity models, so how your results are going to change. Like if the size of the planet is small, the depth of the planet, like Moon is, I think,
1737, yes.
1700 kilometers. What will be its natural frequency? Earth is 6300. So what will happen? Suppose if the whole Moon is some liquid or solid or whatever, so how these things are going to change. So that is more important for us. Okay, so CMT we have not discussed in this course. So you can use the default things. Okay, Meenakshi, continue.
Ah, yes. This told, right, this frame solid, if you want to make a solid thing like from 0 to 6371, the same material properties I am giving, but I'm also mentioning the core mantle boundary as well as the inner core boundary. Like this you can make your own model for Mars, Earth, or Moon. Okay, so this is the total number of lines. I have 4. This is second line. This is where the inner core to outer core boundary, and the third line which represents the core mantle boundary. So this is the top layer surface which is having the 671 kilometers. And next is like stations. So at what station you want to calculate the seismograms? For that they have given some standard stations already. So if you are like, I have considered here at the center 0 comma 0 as the lat long, and I have given the stations like at 2 degree, 4 degree, 6 degree, like that. So I'm making the latitude constant by increasing the longitude. I have given the stations. This is like, if you give different names, if you give different names and with different numbers, you can make n number of stations. There is no limit for the number of stations. If you just follow this format, you can get you can change any lat and longitude of this station, and you can get the seismograms for that particular station. This is the site, but we have also have to give the station orientations, whether which is like 90 to 90 degrees, or what, east, north, and z component, how we are giving. So for each station 3 components will be there, and their orientations will be 0, 90, 90 is E, north is 0, 0, 90, and z is 0, 0, 0. So for every station you have to give all these 3 things. So if you follow the same thing for if you have 5 stations, 5 times 3, 15 short dot side channels you have to give. So once you give it, then you can go for the running the next programs. So the inputs are clear, right? Or do you have any problem, or you can ask me now itself.
Yes.
Yeah, fine. So now I'll show you the first, like there are 3 ways you can write all the, if you have gone through the this already, this thing, like manual, they have already given the how to run it, like using some command lines, or using you can directly give it as a, like this it will ask each and every command, it will ask and you have to give the input. Or otherwise you can directly give a file name with all the parameters, and you can simply run this command. Or you can use some shell script, and you can use that another thing also. But now I am using this interactive dialogue thing. I will show you each program how to do that. Okay. So the first thing is Mineos brand dot slash Mineos brand. If I give, it will ask the input model file. For me, it is frame notion.txt. This is my input model file. Output, where the eigen values are stored. Now I am giving frame eigen, and this is eigen functions. It will be stored. I will give frame output, and EPS and W grave is like till what frequencies the gravity will not be considered. So that is, this is the accuracy, as well as the W grav I will give till 1 hertz. So after 1 hertz, the gravity it will not consider. And JCOM. This is first one is radial, second is toroidal, third is spheroidal. So I need first now spheroidal motion. So I will give 3. And this is the like sir showed already, right? That angular order L, N, that overtone, and what are the maximum and minimum frequencies you want to compute. That I have to give. I will give 2 and 100 as the angular order. W means 0, and W max I will give 100 millihertz. It means 0.2 t. This code will run only till 0.2 hertz. So before, between that only you have to compute. And n min I will give 0, and n max, so till 20 modes I will give. So I'll run it. Okay, 1 second. You will get some like different kinds of photon errors. You can just go through it and see it, like how you can avoid it. Generally, if you do it properly, you may not get anything. Like this it will come and it will end, and I will show you that what is this prime eigen. This is the prime underscore eigen, is the where eigen values are stored, right? I will show you that. If you give vi eigen means, it will show you that. So this is the material properties that is we have provided. So here you can see for 0 mode, and this is the angular order. Yes, this represents the spheroidal mode. This is the phase velocity. This is omega in millihertz. This is the period, group velocity, q, and Rayleigh quotient. These are all the values for, if we have given like till 20 modes, right? So till 20, and the angular order I have given for 100. So for every mode till 100 angular order, it will give the values. So you can use this file and you can plot this results. So is it fine? These are the where you understood, right? What are the inputs, how we have to give, and how we have to see the output of the eigenvalues. Okay. So once we complete the eigenvalues, we have to go for eigcon. This is dot slash eigcon. You have to give what is the motion. I mean, we are considering, we have already taken spheroidal. So name model file is frame notion.txt. Maximum depth, till what depth of the solid sphere you want to calculate. I am giving 1000 kilometers. You can give till the surface also. Okay, the first Mineos output a text file is frame eigen, if you remember it. And the output binary unformatted m, that is the eigen function file name is frame underscore output I have given. And the path for the storing eigen functions, you can give any name, it will store it. I'm giving test underscore s. So it have already calculated eigen functions. You can see there will be files like test underscore eigen dot dat. Already those files will be created. So now we'll calculate the greens functions dot slash green. So what are the stations and the their locations? It is asking. It is the name short I have already shown you short.site and short.site channel. So the name is short. So the list of modes, if you see, okay, I will show you first db underscore list. db underscore list is the file where I have given this test underscore t. But now I have calculated the spheroidal, so I have to give test underscore s. If you want to calculate both at a time, you can write test underscore s and test underscore t, and you can calculate also. So once if I give short, this is name of the file. Okay, db list. CMT solution, I have shown you China CMT event. Maximum frequencies I have given 0, 100 while I am running this Mineos brand. The same you have to give here. So till what length of the file, like if you have given the time step as one, if I am giving the total points in the Green's functions as 30,000, so 30,000 seconds is the time history will come. So according to that you have to give. So maximum it can run only up to the 30,000 values. So I'm giving 30,000. So Green's output. So once you calculate the Green's functions, in which, in what is the name of the file you want to store the output, it is Green. So for every station and for every channel, it is calculating the Green's functions and it is storing it. So if you see ls minus ltr, so this disk relations, already this green.wf disk is already created now. Now once the Green's functions are created, then it is calculated for the like unit impulse. Now it have to convert for the using the half duration, it will do the convolution and will get the final synthetic seismograms. For that, dot slash syndat, this cmt file is China cmt event, already I have showed you. So tensor type, whether it is a moment, nodal plane 1 or nodal plane 2. Right now I am considering moment based, not based on the strike, dip and fault. You can also give directly 0. And then input db name. I have given green, right, for the calculating, for storing the Green's functions. And output db name, I will give syndat. And whether you want acceleration, velocity or displacement, I need velocity, I will give 1. So it is calculating. So already it calculated and have given this in that. So these are all the binary formatted files, but you need in ASCII format. So you can do like to sac. Cuts to sac is a command where if you give minus a and then if you give syndat, the output where the final synthetic seismograms are stored in the binary format, and you give the folder name where it will store all the ASCII files, like syndat.ac is the directory, syndat is the file name. If you give this command, it will calculate, it will change this binary format to the ASCII format. It will take 10 to 20 seconds. So if you see syndat as underscore asc is the directory, you can see. You can see, right, LHE, LHN, TLY, all the different stations, it is created in the ASCII format. If you want to see, okay, so ALE. LHE yeast file, yeast component file. You can see the first column represents the time and the second column represents the velocity for which event and the station and its location and how many points are there, everything, all these details. You can directly save this file in Excel file and you can plot it, or you can use this in MATLAB and you can get the time histories. These are the 4 steps that you have to follow while in order to calculate the synthetic seismograms using this Mineos. So if you have any doubts, you can ask me.
So Meenakshi, you can show example, no?
Yes, sir.
Time history is what you have plotted, but PPT is there.
Yeah, sir. I will show. So this you have seen, right? I have given angular order to 200, those combination. For that, I have already plotted for frame no ocean. all these steps, everything, like what are the names of the files, you have to give everything. I have given in the PPT, you can see, and this command also I have given, you can check it later. So this one, so you have remembered, right? Like I have given from 0 to 4 6, like at different longitudes I have given the stations. So at 4-degree epicentral distance, this is the velocity for transverse, longitudinal, vertical. Generally it will give for the east, north and the vertical component. You can convert that into the longitudinal, transverse and vertical using this moment rotation matrix, the tensor, that you can find it in iris website, how to rotate it. So at 150 degrees, these are the time histories. So you just have to open that syntax file at which station you want to get it, and you can simply plot column 1 versus the column 2. And and also I have done for the different frequencies. I have showed for the 100 millihertz, right? When I have done while doing it, you can do for 50 millihertz and you can do for 200 millihertz, and you can see the sensitivity, how these synthetic seismograms are changing. And also I have shown you for spheroidal, but toroidal, how it will change. You can see that the importance of the toroidal in case of transverse is less, whereas longitudinal is less compared to the transverse. Like that, you can also run for a different variety of problems and you can check it. And I have already shown you this prime underscore eigen, where I have shown for n equal to 0 spheroidal mode, what is the omega in mhz. So that you can plot like this. For spheroidal, this is the plot, angular order versus frequency, and for toroidal modes, this is the angular order versus frequency. And also I have shown you the phase velocities and group velocities for spheroidal modes. So if you have run the toroidal modes by giving, instead of 3, if you give the 2 in case of while running it, so you will get the toroidal mode phase velocities also, and you can get accordingly their synthetic seismograms. Here all the inputs and how to do that and what are the names are provided. So you can follow this and you can do it, and if you face any problems you can ask me. And I will also share this aqua account thing, and once I will show you how to enter into it. And okay, SSHC18204, this is my roll number, aqua.iitm.ac.in. So once you will get Meena1996, this is my password. So I have already Mineos file, I guess. If not, you can, yeah, I have already this Mineos file. I have already untagged it. I will give you my account details and I will remove this. You can upload and you can do it. CD Mineos, if you go, there already this configuring I didn't do, but you can do it from that process and you can also do it. So the same process, whatever I have showed you in my desktop, you can do it from here. So is that clear, right? Either in your, if you have any Unix system, you can do it, or in this aqua account, I will share you the details. You can do it from here. Got it?
Yeah.
Okay, so some people may ask like how to enter into this. There is a Mobaxterm terminal for Windows people, whoever having the systems Windows. If they have to use this aqua account, they can use this Mobaxterm. Okay, so you download this Mobaxterm and you can give directly here also the same my account. So if you want to upload any files, you go to this, you can upload to the current folder, you can give, and what is the file you want it, and you consider that file and you give that. And so that instead of this tar Mineos file, how you can see, it will automatically will the tar.z file will come into your thing. So do it in scratch itself, don't do before the scratch. Whatever the things you want to do, you do it in the scratch. So is it okay, right? So the Windows people, download Mobaxterm, go into this account, If you want to remove and upload your own file, and if you want to do, you upload it and you do all the configure things, and you can run the 4 programs how what I have shown you, right? So any doubts or any problem you have?
All of you start installing and then start running. So definitely once you run, you will get lot of doubts. Okay. So then you post it in WhatsApp. So she will clarify and
Yes.
okay. So the main target is so you should be able to do these things, which I showed you. To see, right? See, like for example, sir. So this is for the Mars. Okay. So the velocity model is available. So these details also we will share you the papers. So once you know the velocity model for Mars, sir, just in Mineos you have to give the data file, and then you see. So they have simulated. Some there is some earthquakes. Sir. You can use a default CMT whatever it has, because I don't expect you to understand this one. So they have simulated. So this is epicenter here, sir. So now at B, at A, at L, at K, J, how the time history looks like. Okay. So this is what I want you to simulate, and then you can do it for Mars. So velocity model is available. So everything remains the same in that Mineos. Only Earth velocity model, that frame preliminary reference Earth model. So similarly for Mars, we will use this velocity model. And if there is moon, say, so we also have a velocity model for moon. So you take one here, one Earth, and you just simulate for the default earthquake, and then get me this time histories, and then you can even plot like that natural frequency of all the modes. So the spheroidal modes you plot, toroidal modes you plot, and then you observe the differences between all those 3 planets, and you make some conclusions actually. Okay, what is the first natural frequency of moon? How much it is different from Earth? What is the reason for that? So you can try all these things itself. Okay, so this is going to be your assignment. So you please start working on this assignment, and then so that you will understand in great detail once you do the assignment, rather than teaching skills. Okay. So no need to worry about this mathematics. So this mathematics is only just to have an idea how that code works. Instead of looking at like a black box, which differential equation you are solving. So that's what is in. So the main intention is you run the code and then get me the natural frequencies of Moon, Mars, as well as the Earth itself. Okay. So is it fine? So Abhilash, you have work account right in Aqua.
No, sir. I have to upload.
So I think for you there is no issue. You can directly start working. So Kshitij, I think you don't have right there. So what Meenakshi, you just help him. He's a second year BTech.
I've shared my credentials to him, sir, so he can work on.
Maybe your files you don't share. If you share your answers, everything.
Yes, sir.
Follow. Right? Let him run everything from scratch. So
Hmm.
Kshitij, you are familiar with Fortran?
Yes, sir.
The Fortran language. Are you familiar? Kshitij, we are unable to hear you.
Rejoin this.
You are able to hear Meenakshi? Okay, anyway. So you follow, right? So you help that well. I think Utkarsh is also there. He has not come for today's class. Okay. So once let them start.
Okay, then.